This next topic is a continuation of everything that we've talked on this stage, and it will be even more. Private 5G networks, mentioned a lot actually on this stage and on others, and for a reason, as per some data, they're growing more and more than 2,400, at least the number I found, probably even more this year. But in the same time, we have Wi-Fi 7 being installed, Wi-Fi 8 being tested, so which technology will win? Or maybe it's not a fight. Maybe it's not a fight and the real winner is the end user who chooses the right technology for his solution, for his conditions. So let's find out what our speakers think, and the man who will pull that information out of them is the Senior Business Development Manager at Comcor, Mika Skarp. Welcome, Mika. Joining him, the CEO of Weaver Labs, Maria Lemarosas. Welcome, Maria. Next to her, CEO of Is Wireless, Dr. Slavomir Pietschik. Welcome. Representing our very own LMT, its Head of System Integration Business, Kārlis Vilciņš. And next to me is the Vice President of Business Development at Ericsson, Dustin Lamascus. Welcome, Dustin. Have a great conversation, gentlemen and lady.
Thank you. So we will dive into the exciting world of private mobile networks. But before we do that, so let's have a little bit of a background. Who do we have on the stage? So Kārlis, could you tell what is your point of view to the topic?
Yeah, basically, first of all, to introduce myself, as you probably said already, I represent LMT. So we are MNO, largest MNO in Latvia. But regards to private networks, private 5G networks, we are actually system integrator. And our role is actually to really understand the customer requirements and build the 5G private networks, not only in Latvia, but also in export markets. So my role is actually managing all of this business, all of the real communication with the customers, with vendors, putting it all together in a working, nice solution.
Okay, Slavomir.
My pleasure to be here. Thank you very much. I represent IS Wireless that I founded and that I'm leading right now. Before IS Wireless, I had one more company that was doing communications, but more in a 4G area. Before that, I was a specialist at Deutsche Telekom. Before that, I was a researcher at Delft, where I did a PhD. So communications is with my entire career here. And IS Wireless is developing and delivering dual-use private 5G. So that's a private 5G. This is the type of private 5G that is working where other solutions do not work or cannot work, which is extremely resilient, secure, and efficient. And that's the angle of attack, I would say, that we took as a company, and I hope to share more with you today about it.
Dustin.
Yeah, thank you. Pleasure to be here as well. So Dustin Lamascus, I'm working at Ericsson, and as many of you might know, we do 5G. We do 5G radios and cores for MNOs like LMT globally. My focus at Ericsson is with private 5G and really enterprise 5G. So I lead a business development team with global responsibility. As maybe you'll see in part of the conversation here, highly focused on industry verticals because we need to speak the industry's language. We need to understand their problems and how to solve them. So my team is organized not geographically, but rather by industry vertical. Thanks.
Okay. And Maria.
Hi, Maria Lema. I'm CEO of Weaver Labs. Weaver Labs, we build telco cloud orchestration software. And what that means is creating platforms where private 5G or any type of enterprise networks can exist. Bridging the connectivity layer with the value add layer, which basically means why anyone would invest on an enterprise network. And our software is basically an NFV orchestrator, so it automates the creation of the cloud environment and it deploys the workloads across the different network infrastructure elements.
Okay, so we have a huge amount of experience on the stage, and we have also the different kind of companies. So small vendors, operators, and system integrators. So I think that also shows us that how versatile the ecosystem is in the private mobile network. So it's not like a miniature mobile network that operators are doing, but it's something different. So let's dive in. So Maria, what kind of problems your customers are solving with this technology? What's the reason for it?
That's a great question, actually. What's the reason for private networks in general, right? So every single industry wants to adopt innovation, and that innovation usually sits on top of infrastructure. And regardless what type of infrastructure that is, it's compute, is storage, is transmission coming as a whole, right? Some companies decide to outsource that infrastructure into hyperscalers, but some companies need some sort of infrastructure on site. And networking is just another element of that infrastructure that supports the innovation that they want to adopt. So the problems that we see are usually, they are business problems when it comes to adopting that sort of innovation. So we've worked in different, I hate the word vertical, but I guess we use it in this context.
So what would you use instead of vertical?
Different business areas or enterprise customers, but it's just, I understand why it's a horizontal, like infrastructure, vertical industries. But we've operated across, smart cities, public sector, ports, high-density venues, and almost at all of them, what we have seen is the common denominator is that they want to adopt some sort of innovation that is going to make them either save money or make money. That's pretty much it. Recently, because we need to focus on the monetization of the networks and what actually drives that investment, we're looking at areas or enterprise networks that are directly monetizable. And we're focusing on stadiums and high-density demand spaces like arenas and concert spaces. And the reason is because there is a strong need to appeal the end user. And there is a very direct path to monetization. So you can follow the money because you can follow the use case.
Can you give any example that practical example?
Yeah. So in one installation that we're working in the UK, we've integrated an AI assistant on the cloud on-prem that it's giving insights to the fans based on how the match events are progressing. It's giving insights on what's the likelihood of this red card impacting the result of the game. We've also integrated 360 camera views for the fans to have different angles to see the match live. We've also integrated Wayfinder so that they can navigate and find tacos instead of chicken wings because they prefer tacos and they don't want to go to all of the food stalls around the venue. And more recently, in a collaboration that we have with Bell Labs, Nokia in the UK, we are integrating computer vision for player tracking. So we've overlaid all of those information elements. So the video is overlaid now with the player tracking, and the fan has all the information that they would have if they were watching it on TV, right? So the miles that this player has been running, the speed, the jersey number, and things like that. So all of these augmented information that makes the match a lot more enriched experience. And the reason why we can deliver all of that is A, because we have an edge cloud running on site with CPU and GPU workloads and the ability to abstract and deploy applications that leverage that. And we have a combination of Wi-Fi and private 5G. And on the backhaul, we have fiber and satellite as well. So it's a very enriched combination of technologies that deliver that fan experience and that ultimate business case for them.
If we think about that, if we had not the 5G there or the private network side, so what would be missing from the fan experience? What would be
It's just the capacity. So the limitation that we were experiencing was that without the private 5G, we were not able to deliver the capacity that was needed for the, especially the most immersive use cases. When we are talking about crowd games or we're talking about AI insights that are delivered to the phone of the fan, maybe private 5G is not as needed, and a very good Wi-Fi network can do that. However, the other limitation that we have seen with some of our customers is that Wi-Fi technology purely for coverage perspective needs a lot of access points, and some stadiums that is really hard. So from a coverage perspective, where with Wi-Fi we would need 30 access points to cover an entire bowl, with private 5G, not from a capacity, but from a coverage perspective, with 6, we're done. Right?
Yeah.
So that's the other kind of like lever that we see. It's, okay, how can I mount these access points in the bowl? Because sometimes we don't have access to cabling, or we don't have, sometimes you just literally have to mount it under the seats. The way that these stadiums sometimes have been built does not allow for that sort of densification.
Yeah. I know, Dustin, that this is one of your kind of questions that you get asked, that why not Wi-Fi, why 5G? So how would you answer that question?
But that was me?
Yeah.
Yeah, so I see the two technologies cooperating, right? And I like to use the analogy of Ethernet and fiber. They're essentially doing the same thing. They're connecting. The same thing with Wi-Fi. Wi-Fi has great attributes around scale of economies. It's cheap. It's typically easy to manage. Everybody has a Wi-Fi chip on their phone and their device. You don't need a special chipset. But then when you come to private cellular, private 5G in particular, there's certain technical attributes there that Wi-Fi just doesn't have. I would say the first one is spectrum. And I know that's a complex topic, so I'll tiptoe lightly around the spectrum one. But typically, Wi-Fi is using shared spectrum. Anyone can use it. With private 5G, you're either using licensed spectrum or lightly licensed spectrum, which means there's protections in place. So if you're doing something that's business critical or safety critical, you definitely want better spectrum. The other thing is mobility. As we all know, 5G, 4G, 3G, 2G has all been built with mobility from the ground up. And so if you're trying to connect people or devices or whatever that's moving, Wi-Fi is simply an inferior technology just because of the handover technique that it uses. Security is the last one I'll touch. I could touch a few more. But with security, you're authenticating the network and the subscriber. It's bidirectional. It's encrypted. Yes, there are security techniques within Wi-Fi, but again, it's inferior. So what we see at Ericsson is that we're not replacing Wi-Fi. In fact, I always say, hey, if Wi-Fi works, use it. And for me, being in business development, that tells me, hey, if their use case is supported by Wi-Fi, we shouldn't exhaust any more effort trying to position 5G. But the reality is a lot of the use cases that our end customers are deploying in our verticals, like manufacturing, mining, ports, energy, oil and gas, they have use cases that require mobility, they require security, they require predictability in the performance. And those use cases typically are enough to fund the investment of deploying a private cellular network.
This is a tough one for you, but if you kind of compare the cost between let's say some port, for example. So how would you kind of compare the developing or covering the port, let's say free port of Riga by Wi-Fi compared to the 5G?
Yeah, so we've actually done a pretty detailed study. It's available online. Maybe if you search for it, you'll find it on Ericsson's website. If not, look me up. I'm happy to provide you with it. But the Cliff Notes version of that study is that it can actually be quite competitive in certain scenarios, right? So if you have a 5G radio or access point and you have a Wi-Fi, there's going to be a 10x scale or something between the price points between the two. But what you'd have to realize is that the amount of coverage and capacity you get with a Wi-Fi access point is roughly 1/10 what you would get with a 5G small cell or radio dot from Ericsson. So automatically you're starting to see some parity in the radio network. And then if you're doing an outdoor deployment, as many of you may know, Wi-Fi is quite challenged in an outdoor environment. It becomes even more competitive in that environment. And then when you look at the overall cost, things like electricity. Electricity is not free. If you're driving 10 wireless access points for every one 5G access point, you start to actually see a return on investment in your OpEx as well. So while I can't give you absolute, figures, I think, if it's outdoor, if it's a larger deployment, you'll see private 5G actually be quite cost competitive with Wi-Fi. Now the flip side of that is usually the Wi-Fi is already deployed. If you have a factory, if you have some outdoor coverage or whatever, you've got Wi-Fi deployed. So it becomes more of an addition and not more of a competitive environment. And then it's just a matter of segregating out those use cases. So you may have some use cases that aren't business or safety critical, and you would keep those on the Wi-Fi plane, and then you would move your business and safety critical use cases into your private 5G. And by doing so, you actually enhance the performance of your Wi-Fi network because it's less loaded now. And you're guaranteeing the performance of your applications that are critical.
But Carlis, what do you have actually done that port?
Yes,
So what is
that's
your...
actually what we did in Rigaport. And our experience is, first of all, it very much depends on the real use case at the end. And the real site. If, like Dustin said, if you talk about large areas, about large warehouses, building 5G private networks, if you do it efficiently, it's actually on par with Wi-Fi costs. And what else you should remember all the time is with private 5G, you start to guarantee something. So you're actually providing a managed service, not a bunch of hardware devices that you're spreading throughout the territory, but you are actually delivering the service that's working for the customer with a certain SLA. And this is very competitive when you start comparing and you see that at CAPEX level you are perfectly competitive, and an OPEX level you get the extra service, so then this business starts going. Yeah.
Can you please open up a little bit that, what does it actually mean when you build a private mobile network? What do you have to do in practical terms?
Actually, first is talk to your customer. First is what the customer really needs, because sometimes we think that the customer needs some crazy automation and some autonomous driving, some AGVs all over the terminal, but customer maybe just needs simple, good, stable connectivity. And this is very much actually influencing the decisions about the level of investment that has to be made. Because as we did in Riga, you can do it very efficiently. If customers' requirements is to ensure the business critical, some business critical main applications, and they don't want to stream live videos from everywhere, then you can do it very straightforward, very simply, very safe, very resilient. At the same moment, think about redundancy if it's important for the customer, and do it at the right investment level. So first is talking to customer, then it's of course finding the right vendors, finding the vendors, and there are a lot of them, like Ericsson, like hundreds of others who work together well, putting all of this together where you can actually build this trustable solution that there is no need actually for everyday service. You connect it to your network operation center and enjoy the service, basically. That's the thing. And third, of course, it's the financing model, and it's how you offer it to the customer. And this is what we are discussing all the time. How much OPEX, how much CAPEX, what's the customer wish list? And then finding this right model so the customer gets what he wants, it works for his use cases, it's the right technology at the right price.
Okay, Slavomir, so you are, well, not that known vendor yet. I think that Ericsson, everybody knows Ericsson, but IS Wireless is a little bit less known brand name. So how do you see it? And especially then, looking at the security, public safety, dual use. How do you see this project?
Being an underdog is not an easy game. Yeah, just a word referring to 5G versus Wi-Fi. There is yet one more argument in favor of 5G, especially the one that is built with this open and disaggregated approach. And this is the presence of RAN intelligent controller that can be used to customize quite easily the underlying 5G network. And that's not present in Wi-Fi. So Wi-Fi comes as it is, and whether you take it or not, that's your decision. I like the point that Maria made about what is the essential problem among her customers, the capacity. and this problem will be much more prevalent into the future. I would say that this is a contemporary digital exclusion. I live in the suburb of Warsaw. It's a municipal area, not exactly by the road, so I didn't have an access to fiber for a long of time. You know, the mobile network parameters, KPIs, are great while nobody is at home. But when everybody is at home, they are under 1 megabit per second. So if you want to use services, you cannot. And that's the digital exclusion. Of course, you have the coverage, but the service is not available. And that happens, it varies temporarily, of course. It happens to very well-developed places, and it happens also to very dense places. And the root cause of this lack of capacity, as we see it, is very poor management of underlying resources. Now, we talk about physical resources such as compute. As a matter of fact, all base stations are just the software running on a computer with a piece of antenna. And the bandwidth, the spectrum, how it is utilized. And it is utilized up to at most 10% at most of the time. Sometimes maybe 20, but it's completely wasted. Now, should we be surprised by this? I think not much, because 80% of the 5G RAN market is addressed by just 3 players. Do we have competition? I'm leaving this question open here. Now, moving into the defense, because we took a direction towards defense, these problems are much more visible on the defense side, on the dual-use applications, because not only the resources are very scarce there, because they may appear and disappear, they can be destroyed. The adversary can destroy the actual physical assets, right? So these are the computers, these are base stations with a spectrum. So you need to live in the realm of scarcity, huge scarcity of resources. Now, the major problem in Ukraine, for example, is the electricity and how to drive with your power banks the actual electrical devices. So you need to really squeeze as much as possible out of the available resources. And this is how we come up with our solution. We call this approach towards networking, especially radio access networks, which is the most physical part of the network. Some people are saying that this is the gate to physics, and I like this comparison. Behave like a liquid, so that you can actually pour the functionality to the resources that are available. And once they are not available, the functionality spills over elsewhere. And this is what we have tested. This is what we have deployed. We have tested this within the NATO Diana program, where we are proud to be selected among only 15 companies chosen out of almost 3,000 to be provided or to be named as a solution providers for NATO. Now, these resilience functionalities have been tested and deployed commercially right now. And they give not only a very effective use of resources, but also extreme resilience once those resources become unavailable in case of a conflict. And the conflicts that we should face, they do not necessarily mean a hot war, like, you know, that the bombs are... we should be ready for what is right now part of what Poland is actually experiencing. This is the threat under the threshold, where you don't know whether it's a war or not war. You know, things are happening, but you don't know why.
By the way, that's a very interesting point, and so true that in the private mobile networks, that a base station, I actually disagree with you that it's a computer, but anyway, so that the base station can be actually tailored for the use case. So Maria and Carlis, what do you think? So when you are selecting the base station vendor, so what kind of topics you see there? What are the most important things? Maria, maybe you start.
Yeah, and it all comes down to the customer needs, right? So initially in the early days of private networks, you would go to a vendor and you would get exactly the same code base with all of the features, regardless of the use case. Whereas now, because of microservices and the way that companies are structuring the software, you can get leaner products that attend to the use case. So we have a large network of partners, and I don't think we have two deployments that are exactly the same when it comes to the solution. Because as you mentioned, right, some would require mobility, but then some others, if you just don't have, like if it's stationary sensors and you just want 5G because of the low latency, then we probably don't need all of that functionality included from the RAN all the way down to the core. Or sometimes we even distribute the UPF, which is the gateway function, just to provide a local breakout point, and then we just have a central location with all the control planes. So the modularity that we have with 5G private networks is really good to play around with the architectural design that would attend to the use cases that we're implementing in any deployment. And this is one thing that you can do with private networks, you cannot do with public networks. And some of our customers also are kind of like debating themselves, should we invest in a DAS system that provides just bare bones connectivity, or should we go for a private network, right? Private networks have a high entry barrier for users to connect. You're a regular consumer, right? But then they can implement other things that they cannot have with a public network or a traditional DAS system, namely control of the traffic. You create an environment where all the information of your customers stays there. And that's another element on how to choose your partners when you're creating that system integration. Do I need to create a private network because I want to have control of the data, or can I just go with a DAS system and just provide bare-bone connectivity for the end user? So there are so many aspects to weave into the actual tech stack that you end up choosing. But definitely the ecosystem for private networks is a lot bigger. The options to buy from and the innovation that is happening from an architectural perspective is great to see. Like I'm a researcher coming from system level architecture design, run 4 in 3GPP, so I love to see all of that.
Carlis, what do you think?
Yeah, this is like an everyday task of system integrator, understanding the customer needs and trying to make this architecture so it works financially and also functionally. And sometimes one thing is finding the things that you put on the tower, and yes, you have some frequency limitations, some power limitations, and you can work with that. But then there are those limitations on the ground. Where is the fiber optical cable coming? Where is the real tower, the real 30 or 25 meter high tower you need to get this outdoor coverage, for example? It's kind of a simple question, but it is a lot influencing the implementation actually on the site. If you don't have it, you need to go through a certain planning process. And from the other side, actually, what we haven't yet talked is devices. And it's a huge challenge in 5G. If you say, yeah, Wi-Fi chip is in every device. No, if a customer has some certain application and he needs a window tablet with a 5G modem, and you are in the market, especially if you want to run some cybersecurity tests on those devices, it's not like you have hundreds of them, and customers won't live with the dongle in the tablet forever. It's like not a real solution that you would offer to somebody. So. One is base station, and of course it's radio planners doing a lot of job to do it correctly and most efficiently, but we need to think where we put it, how we do it redundantly, and what the customer at the end, what will be his end user devices. That's also, I think, the biggest challenge now in the industry.
Have to give a Dustin as also a word that from the big vendor perspective. So how do you see that?
Yeah, so it's an interesting question because you're asking, how do you select your RAN vendor? And my answer is quite simple: we'll pick Ericsson. But then, flipping it on myself, how do I make for sure that Ericsson is the most attractive RAN vendor to be selected? Right? It's a very competitive market, as we know. At the top end of the market, the lower end of the market, it's very competitive end to end. At Ericsson, we spend approximately 5 to 6 billion euros per year in R&D to ensure that we have the best radios and software running on those radios. We can do that because we have the scale of our MNO customers like LMT that help fill our coffers. So within inside of Ericsson, the enterprise division is actually a customer of the same network division that's building those radios. So we work cooperatively with our network team to bring feedback from the customers, the functionalities that are needed by our enterprise customers. At the same time, understanding all these features that are being built for the operators and adapting them for the enterprise world as well. So it's a very active component. And then on DAS, one of the ways I think we're trying to be very attractive is we're creating multi-band dots. We have a dot radio system. And for example, we have a dot that supports 4 different bands. So you deploy something that looks like a fire alarm, about that scale, and it supports 4 different carriers simultaneously. So for example, in the US, you could have AT&T, Verizon, T-Mobile all on that in a neutral host, and you could still have a carrier available for a private cellular network. So when you go into like a hospital or something like this, that starts to become really attractive because the barrier of entry for private 5G is maybe too much in some of these settings, but they're already spending the money on the DAS. They're going to be modernizing, to the next DAS or active DAS or whatever. So it's, I think it's a requirement as a RAN vendor to ensure that you're relevant in that. And knowing that we're at the premium end of the market, we need to ensure that we're bringing a premium product to the market as well.
So you don't see a kind of a big difference from the RAN vendor perspective, that if the end use case is a private network or the public network?
Well, there's absolutely some deltas there. I would say, just on a Venn diagram, it's largely overlapped, but there are definitely some edge cases there. One key case is uplink. MNOs are still primarily a downlink network, and a lot of the features and functionalities are built around downlink optimization. Well, there are some features and functionalities for uplink optimization, so we need to ensure that if we haven't developed those already, we pick those out of 3GPP, we get those developed, we get them implemented, we get them tested.
That's by the way something that's what we can do in the modern base station is that we can actually optimize the base station for the uplink or downlink. We can make compromises there, and that's something that has not been possible in the previous generations, and there are a lot of things that can be done. It goes beyond the TDD frame structure, that how many slots we have. But hey, I want
to make one more comment real quick, because devices, you brought that up, that is a real challenge.
Yeah.
We're largely not a device vendor. We do have Cradlepoint, which we purchased, but when we look at the whole portfolio of devices, that's only addressing a small component of that for private cellular. So part of my team, actually based in Sweden, is dedicated to testing third-party devices. So we bring the devices into our lab, we certify those devices, and it's all public information. So again, if you go to ericsson.com, you can find this. But some of those devices actually compete with our own internal portfolio, because we're focused on bringing to market what will testing and delivering what will connect to our private 5G network and ensuring the best performance.
Slavomir, what kind of a devices the public safety or this kind of a dual use case things are using? What kind of stuff is there in Ukraine?
So first of all, there will soon be no more base stations, guys, and I think that this is the old concept that we should abandon, because look, what is base station made of? There is an antenna, there is RF front end, there is some real-time processing needed, some, let's say, near real-time and non-real-time processing, right? So there are different workloads that you can smear over the available compute power. Now, it only happens by chance that all these functionalities for the ease of implementation, are put into one box and called base station, right? But it will not be for long, because we will not have a luxury of designing where we want to put a base station. This is the old paradigm of building the networks, that I have the luxury and pleasure to say that here is my base station, here is my cabinet, here is this and that. The point is that in order to do so, you need to control all those assets. But they are not possible to be controlled by operators anymore, because there are other players that are able to control these assets much better. And that boils down to controlling localizations with fiber, with electricity, and so on. This is where Maria work fits very great, because what we expect is that there will be a plethora of offering of various assets available to be used. So you need to use what is, not what you want to be, because everything what you want to install costs you a lot of money. And what is doesn't cost you that much money, because you can share, you can balance, you can use those resources that are already there, right? So this is a different paradigm. And I think this is the essence of what we see in defense. Because in defense, those resources are scarce by nature. They can appear because, let's say, there is a zone that got destroyed and what we call the base station is down. So territorial forces arrive with a mobile vehicle, with an infantry vehicle, whatever, and they have on board an edge server that can be used in providing, helping out, solving, healing this network problem that is there, right? So you need to have a network layer that's available to adapt to the resources that you have on the side. And that's why I think that there will be no longer base station.
Yeah, just to continue, actually, this not new concept of distributed core network. So you have a lot of
I'm talking about RAN. Core is, of course, the easier part.
But this is also very well supporting this concept that you are spreading it all over, basically, and also private networks. You will have a lot of small cores over some territory, exactly like you're talking about RAN. So it's becoming more spread around.
So we do a lot of work on distributed compute and treat the network as a service running environment, where is the application that dictates how the network assets come together, and then the orchestration layer is the one that deploys the workloads over all of that infrastructure that is available, including the RAN components. However, as much you won't find any more supporter than me in terms of softwareization and distributed networking and service running environments. We're still not there yet, because there is an element of hypervisors that it's just so hard. And specifically with the upper PHY layer, that we find very limited CPU capability that allows us to run that in container environment. So we've managed to do containers, but the architecture becomes really, really hard. And then the other element that I think is preventing us from really going into that fully distributed approach that private networks need is the fact that some vendors don't offer us the possibility to
open up interface,
to distribute software across. It's still very much software and hardware together. I sell you a box, right? Whereas private networks, if we look at how Microsoft conquered the enterprise market, is about building blocks and flexibility, and those building blocks and flexibility only come if I really separate the box from the logic. And it is coming because some vendors, because they need to fit in some other bucket, they do open up their software, and you can work in that kind of like environment. But it would be great if we could have more of those.
Okay, I think that's a good bridge to the next one. So how is the future? So what kind of prediction we can tell if we start from the Dustin? So what do you think?
Yeah, so that's a very open question.
2030, where are we with the
2030. Oh wow. We were having a really good discussion earlier, and I want to maybe not talk about the technology, but talk about the business. And what I'm seeing at Ericsson is that we're very successful. We're seeing growth at the top of the market. So Newmont's a global mining company. It's the largest gold mining company in the world. They're a client of ours. Jaguar Land Rover, Airbus. I mean, these are our clients, right? So that's who's adopting the technology today. And we were theorizing why that's happening. And I think it's quite obvious that these organizations have the resources, right? They have the financial resources, they have the staff to be able to investigate, understand the business outcomes, develop use cases, bring in the connectivity pieces. It's complex, but they're adopting it at the top of the market. So I think when we get to 2030, what we're going to see is the broader market to start adopting the technology. And maybe from the technology side, maybe that's because the vendors have become better at making it easier to consume. I hope so. I know we've spent a lot of effort trying to make private 5G as easy as Wi-Fi. So I see the market broadening and becoming maybe more appealing for vendors like myself. But I also see kind of I'll call it the tier 2 market. Like in mining, you have the tier 1 mines, and you have the tier 2 mines. You have to make it very consumable. You have to make it easy to deploy, click to deploy even. So that's my prediction for 2030. And by the way, I've been doing private networks, not as long as you, but I've been doing it for almost 10 years now with Nokia before Ericsson. So it's pretty rewarding to see where it is today and be having this conversation today. Yeah. But very exciting, looking forward.
Kallis.
Yeah, as a system integrator, actually, we are already now trying to focus ourselves on tier 2, tier 3, and this is where we see it starts rolling, and definitely it will be more and more widespread. We see actually the future is hybrid. Future is hybrid, so still there will be indoors, there will be good managed Wi-Fi 9, 10, 11, something like that probably. At that time, there will be still radio links there will be LoRaWAN, and each of those technologies will have their own specific use case, but the new 6G or 7G core probably could be the one joining all of those technologies together, and this we see actually as the mission of us as system integrator. Build one core that supports all of those technologies, brings them together, and serve the real use case of the customer.
Okay. Slavomir, yeah, what do you think?
Well, I think that technically wise, this open model and disaggregated model will continue, but not in a way it is now widely perceived or accepted, where right now all the big players are also open radio access network, opening up some northern interfaces, but not really those southern ones, because this is where you actually have this vendor lock, this relation between the functionality and hardware, which is absolutely against the customer, because the customer needs to have freedom to select. Now, it will be continued, and my belief is that the network layer functionality, including RAN and core, should really adapt to the network, to the resources as they are, because there will be much more of the offering of those resources available on the market. Now, what is visible in defense right now will very soon be visible in a civilian world. That calls for orchestration of those resources, but also for creating or having an ecosystem where there will be more players, for sure, and absolutely there is a place for the big ones. You know, they could be great integrators of the whole thing, but I think evidently the table where there were just, let's say, only the big operators on one side and big providers on the other side, that's going to be changed, because we need to squeeze more out of what we already have, not add capacity and throughput by just adding new channels and building bigger sites or adding more antennas. Well, that's not a smart engineering. Everybody can do it. You put more into this, you get out more. The challenge is how to squeeze more of the performance out of what we already have. And that is something we should focus on. If we don't solve it, there will be no 6G.
Okay, Maria.
No 6G. I think from a futuristic perspective, the way that I see the world and where my company is kind of like innovating in the space is that I see a world with hundreds of operators that deliver highly specialized services. And this concept of public networks and private networks is going to dilute in what type of customer we are serving. So if it's an end consumer, it's a SIM card that goes into a phone, but it can be a layer on top that is a CCTV safety network on the street that it's operating over shared resources, but maybe operated by another operator. So I want hundreds of operators delivering services over shared access and shared spectrum.
That sounds great. Hey, now we take the one question from the audience. So did we get any questions?
We have a lot of questions on Slido, but audience first, maybe a question with the microphone. Here, please raise your hand. Yes, Dean.
Of course.
Thank you, and thank you for the panel. I'm actually half listening with one ear to a spectrum sharing conference that's going on at the same time. A question on one use that I haven't heard for private 5G much recently is neutral host, where you could use a private network essentially as a way of extending the public cellular coverage by sharing onto a private infrastructure, maybe inside a building or in a remote location. Where are we with that?
Well, that's a panel of its own, but Maria, maybe you want to make it short.
I'm just like literally battling with that one, and I would have loved to have a regulator here, but unfortunately, she couldn't make it. Technically, we are. Like, it's not technically that problem has been solved with like Mocken or many other ways of interconnecting gateways. It's not a networking problem. It's a regulatory problem, because with the shared spectrum access, at least from an Ofcom perspective, we're not allowed to provide public network services over that spectrum. And the consultation was up. Is the result? Yeah, there was a consultation up for that. As soon as that clarity of what is a private network, which services are we allowed to deliver over that public network is clear, then technically that problem can be solved. And I think it would be great if we can use private infrastructure or privately owned infrastructure to deliver public network services and create that offload of capacity.
For the audience, if you are not really an expert in this area, so the private mobile networks, they are data networks. So there is no kind of 112 or 911 services or the location requirements and all. So from the regulation perspective, it's a really a different world than the public network side. So that's a side note. But it's a really, really interesting topic. And also when going to the 6G, because we go higher in the frequencies, so the higher frequencies, they don't penetrate into the buildings outdoors. So something has to change for sure. But did we have a winner from the audience?
Another question?
Yes.
Yes, we do. The most popular question. Satellite lovers are sending their regards and asking, do you think Starlink or similar satellite data connection could compete with 5G and 6G in the future?
Yeah, I'll take a stab at that first. At least for today, I see it being a cooperative technology. I know we have direct to device, and obviously that's going to continue to expand. But that doesn't really solve the problem that we're solving with private 5G at Ericsson. The problems that we're solving are around, number one, latency and predictability. You're not going to get that with satellite because physics. It's not because they can develop a better chip or something, it's physics. But then you also have security, where your data is staying local on the premise. If you're Airbus, you don't necessarily want your R&D data to go over a satellite and Elon to view that. For me, I see it as complementary because I'm deploying private 5G networks in areas like offshore oil rigs or something like this, and I need that backhaul. And it's critical that we have that satellite network that can provide a relatively low latency and high throughput for a reasonable price tag that we didn't really have a few years ago. So it's actually unlocking opportunities for Ericsson to deploy for private 5G.
Now the time is really up, so I think we gotta go. But thank you for listening us and for the great panel. This is a really interesting topic to go through.